about the current environment. What's interesting here is this variable. So we can see that the user agent is being sent and it's being displayed right here. Now the user agent basically is the current browser used by the user. The website thinks that I'm using Firefox, which is correct, and that's because Firefox, every time you open a website, it actually tells that website what browser it is. So this happens on all websites. So this is actually sent from the client. So we can actually modify this value. And what we're gonna try to do is we're gonna modify the user agent value, and we're gonna place code that will give us reverse shell. Before we do that, let's make sure that the code will be executed on the server. So we're gonna send just a normal PHP code that will display PHP information. So I'm gonna turn on my interceptor. Now I showed you how to set up burp proxy, so if you don't know how to do that, go back to that lecture and see how you can set up burp proxy. So I just turned on the interceptor and I'm gonna browse the exact same URL. And right here, if we go on the headers, you'll see that Firefox is sending the user agent right here, and it's sending it as Mozilla 5 whatever. So what we're going to do is we're going to modify this value and we're going to put PHP code. And the code I'm going to put is very simple. It will basically just display the PHP information. So it's a function called PHP info. And then I'm going to forward this packet. And as you can see, the PHP code got executed on the website, on the target website. This means if we send malicious code to this website, we'll actually be able to gain full access, or we can get our code to be executed. Now you can literally send any PHP code you want. You can send code to list files, you can send code to upload a file, or you can send one of the codes that we used before to gain a reverse connection. So that's what I'm going to do. I'm going to use the exact same code that we used before in the previous lectures to gain full control over the target computer. So I'm actually just going to type it down here in terminal and then I'm going to copy it. So we're going to be using pass-through and we're using netcat. And then I'm going to put my IP address. And I'm going to use the port, which is in this attack I'm going to use 8888. And then we put the semicolon. So it's the same, it's just a PHP function. We use that in the code execution lecture. So I'm literally just going to copy this and I'm going to inject it as the user agent. Now before I do that, I'm going to listen on port 8888 for connection. So we're going to use the same code that we used before again with netcat. And now we're listening for connection. We have our interceptor on. I'm going to browse the website, I'm going to hit enter. And I'm going to modify the user agent. Again, don't forget to put the question marks here because I only put the code there. So we have the opening and the closing for PHP. And then we put our code, which is the pass-through code, NCE, bin SH, our IP, followed by the port that we're listening on. I'm going to hit enter and I'm going to forward. And as you can see, we got a connection back using the local file inclusion vulnerability. Now I can browse files, I can do pwd, I can do ls, I can do id, and I can pretty much do anything I want on the server now that I have full shell access. So we were able to convert a local file inclusion vulnerability that can only show you files or can only allow you to read files on the server. We were able to convert that and exploit it to get full access to the target server. All of that possible because we were able to write to the proc_self environ variable which displays our user agent, and by changing the user agent to our PHP code, we were able to run any PHP code that we want. In this lecture, I'd like to show you an example of how to discover and exploit a blind SQL injection. Now, a blind SQL injection is one that doesn't display any errors to you. So we've seen in our previous example Let me just go to SQL injection,
Enemy
and
spotted.
if I just put a single quote here,
You destroy the enemy force. Nice work.
you'll see that it actually displays an error for me, which tells me that this page is vulnerable and I can exploit this page with an SQL injection.
You rock.
In a blind SQL injection,
Don't
however,
screw this
it will
up.
not show any errors for us. So right here in the blind SQL, if I put a quote and execute it, you see that it's not going to show me any errors at all. This doesn't mean that the web page isn't vulnerable. It just means that the website might not be displaying errors and this page might have
Look
a
at
blind
you.
SQL injection. In real life scenarios, I always approach the pages and try to discover exploits in them as blind SQL injections. So I never actually look for errors and I never depend on just inputting a single quote. The way I test for the existence of SQL injections is that I try to inject a true and a false statement and then see if the page behaves according to the statements that I'm given. So if I give it a true statement, it should give me a valid page. If I give a false statement, it will give me an invalid page. What I mean by an invalid page is a page that doesn't look like what I expect, so it doesn't have to show an error. This will come more clear now in the example. I'm just going to put 1 now to see a valid page. So literally I'm just putting a normal user ID and we can see that it's given us a valid page. So it's given us the first name and the surname, and this is what the default, what a valid page looks like in this web application. So the first thing I'm going to try to do is I'm going to try to give it a true statement, a statement that returns a true. And this is going to be and 1 is equal to 1. So this is obviously true. And when I inject this, if the page is vulnerable, it should still show me the valid page.
Objective lost.
So I'm gonna inject it here, and 1 is equal to 1. I forgot to put my comment here. I'm just gonna put the comment. Percentage 23.
Objective secured. Defend it.
And now, as you can see, the page is showing me a valid page, again showing the first name and the surname. So it's executing what I'm telling it. I told it 1 is equal to 1. 1 is equal to 1 is a true statement. It's not going to affect the execution of the page. Now what I'm going to do is I'm going to try to inject a false statement. So I'm going to try to break the page even though I'm given 1, which is a valid ID. So my false statement is going to be and 1 is equal to 0. So that's going to be false.
Finish the job.
And I'm gonna go in and inject it now. And as you can see, the page doesn't show the default valid page even though I'm given number 1. So you don't see any errors like we see with the normal SQL injections, but you can see that the page isn't valid. It's not displaying what it should display even though we're given the ID equals 1. So when we give a true statement, it's given a valid page. When we give a false statement, it's given an invalid page. We can also verify this using the order by. So I'm going to put 1 and then I'm going to ask it to order by 1. So order by only 1 column, which basically is a true statement. It's always true. So
Enemies eliminated.
this is going to
Great
be my
work.
true statement,
You rock.
and I'm going to execute it here.
You rock. You rock. You rock. Match point. Let's get it.
And as you can see now, it's displaying the valid
You need
page
me
that
more than I
we've
need
seen
you.
with the and 1 is equal to 1. So we can also change this to a false statement to give us an invalid page, and we're going to ask it to order by a very large number. So I'm just going to put 10000.
Salut.
So this is going to be my false statement, and if the page is injectable, then it should show me an
Acknowledge.
invalid page, or a page that I don't really expect. And again, we see a page that we don't expect, which means that this website is vulnerable, even though it doesn't actually show us any error pages about the
Objective
SQL.
secured.
Move here.
Now that we're sure that this page is vulnerable, we can actually exploit this vulnerability exactly the same way that we exploit normal SQL injections. So I can just do union, select 1, 2, and as you can see, I can display stuff in 1 and 2, and I'm gonna select table name from information schema.tables, and I've actually misspelled schema here.
You
So the exploitation part is exactly the same, whether it's a blind or normal SQL injection. The only difference is the way you discover it. And I recommend that you always approach your website and try to discover blind SQL injections. So never rely on only using a quote. Always try to use the AND, 1 is equal to 1, 1 is equal to 0, and also use the order by to try and discover this type of vulnerabilities, because if you rely on the quotes, you'll be missing a lot of blind SQL injections that are just as useful as normal
Working on the
SQL
clock
injections.
again, I see.
In this lecture, we're gonna go and have a look on the high security level, and we'll see why it's uninjectable. So let's go ahead first and set the security level to high. And now I'm gonna go back to my SQL
Enemies have
injection.
5 lives left. Keep up the pressure.
And let's make sure that the page works first. So I'm just gonna put number 1 like we always did.
Spotted.
And as you can see now the page works. Now let's try to inject it after the ID parameter like we always did. And I'm gonna put and 1 is equal to 1, so I'm putting a true statement. And as you can see now the page doesn't really work. So let's try to put a single quote here to close it like we did with the low level. And again, this injection doesn't work either, even though we're given a true statement that shouldn't interfere with the current request. We usually don't look at the code when we're trying to hack, but as I said, this is uninjectable. So let's have a look on the code, and we're gonna compare it with the code used for the medium security level, and we'll see what's the differences between the two codes so that we can learn how to secure our websites. So I'm gonna change the security level to medium here, just so that we can compare the two codes. And I'm gonna go back to the SQL injection,
Move here.
and I'm gonna view the source as well. I'm gonna put them beside each other. So in here, in the medium security level, you can see that the ID is being read in here and it's been stored in the ID variable. And then they're using a function called MySQL real escape. So what this function does, it'll go through every character in the ID variable, and it'll look for special characters such as single quotes and double quotes and remove them. Therefore, any quotation marks used or injected in the ID variable will actually be removed at this line because of the use of the MySQL real escape string. Now the thing is, once we go down to the SQL statement, you'll see that we actually don't need to use any quotes to inject code into this statement. So our statement is select first name last name from users, where user ID is equal to ID. So we actually don't need to close any quotes. We don't need to inject quotes in the ID variable. All we have to do is just put any ID like we did in the last video. So we can put just number 1 and then inject code straight away after the number 1. So when we use this code right here, we're basically, we didn't use the quote in the medium. So we are literally just giving the ID as number 1, and then we're saying union select